Hi, so in this video I want to talk about multiplication and division with polar forms. You could probably just do this the longhand way without memorizing any equations, but since we're trying to optimize time for the FE exam, um, these equations are given, so it's in your best interest to know how to use them, or at least know where they're at in the FE Handbook, so that you can utilize it to save a little bit of time. So for me, I hit Control F in my PDF, I hit Polar, and it took me to under the Mathematics heading, um, Algebra of Complex Numbers, Polar Coordinate System, and as you can see here, these are the equations that I've copied on my OneNote. So this is division of polar coordinates. This one here is multiplication, and it kind of gives you a formula, a shortcut formula that's derived for you. And also, this is the variation equation that I've copied down in the first screen here. So let's do a couple of examples. The first example here is going to be, this first part is my Z1, this is my Z2, and basically I'm going to utilize this multiplication equation in order to cut down on my computation time. So just like the equation above, I'm just going to plug and chug. So basically we're going to have R1 times R2, which R is denoted by this 5 and 7, so that's R1. This is R2. So if we follow the formula, this is going to equal R1 times R2, which is 5 times 7. And we're going to take the cosine of theta 1, which is denoted by pi over 4, plus theta 2, which is pi over 3. Theta 2, so pi over 3. And we're going to multiply this, or we're going to add this by j sine of the addition of theta 1 and theta 2, pi over 4 plus pi over 3. And again, that's just following this first equation there. So when I compute this, basically I'm going to get 35 times cosine of 7 pi over 12 plus j times sine of 7 pi over 12. Okay. So when I compute this, I'm going to get an estimated answer of 35. Cosine of 7 pi over 12 is negative 0.259, or approximately that, plus j times sine of 7 pi over 12 is approximately 0.966. So we can distribute the 35 through, and we'll get negative 9.065 plus 33.807J approximately. So that's our answer using the multiplication derivation here, denoted by equation 1. And for example 2, this isn't necessarily practical in a test setting, but I just want to show you, just for extra practice, how we can use this variation equation, because when it's given in polar notation, as you can see here, R1, I mean, this is also written as r comma theta. So if it's given in polar notation, it's a little bit more straightforward. So what I'm going to do for extra practice is convert Z1 and Z2 into polar and use the variation equation to compute, and check with this answer that we just had to make sure we did everything correctly. So for the first one, our Z1, which is equal to 5 cosine pi over 4 plus j sine of pi over 4. We know that this term here is r, so we don't even have to compute r. We have r right away, which is 5. And theta, if you looked at my previous video on polar coordinates and complex numbers, theta is equal to tangent inverse of y divided by x. And normally, if we distributed this 5 through, we would have 5 cosine pi over 4 plus 5 sine of pi over 4j. That's a 4. So this first term here is x, this term here is y. The 5's would cancel out when we do the y over x, so all we have to do is do the tangent inverse of sine of pi over 4 divided by cosine of pi over 4. And of course, sine of pi over 4 is square root of root 2 over 2, and cosine of pi over 4 is also square root of root 2 over 2. So basically, we're just going to do tangent inverse of 1. And tangent inverse of 1 is just pi over 4 radians. So that's our theta 1. Actually, I didn't label that there. And this is R1. And for Z2, we have 7 times cosine of pi over 3 plus j sine of pi over 3. And similarly, we know that this 7 is our radius, so our r, that's a 2, Z2. So our R2 is 7, and theta 2 is going to equal tangent inverse of y over x. Again, the 7's are going to cancel out when we do y over x, so all we really need are the cosine pi over 3 and sine of pi over 3. So we can say tangent inverse of sine of pi over 3 divided by cosine of pi over 3. Sine of pi over 3 is root 3 over 2, and cosine of pi over 3 is 1/2. So root 3 over 2 divided by 1/2, which will leave us with tangent inverse of square root of 3, which equals pi over 3. So this is theta 2. So then Z1 times Z2, according to this equation here, is basically just our radius 1, which is known to be 5, times radius 2, which is 7. And the angle is going to be the sum of theta 1 and theta 2. So that's just pi over 4 plus pi over 3. And this is equal to 35, and the angle is 7 pi over 12. And really this notation here, this is the same thing as saying 35 comma 7 pi over 12. And in order to check to see if this answer lines up with our first answer here, what we can do, we know that x is equal to r cosine theta. So our r here is 35. This is our theta. R is 35 times cosine of 7 pi over 12. So that's our x. And our y is equal to our sine theta. And this is by definition. Again, I did a video, one of my previous videos, I talk about this. But you can also find this equation in this under the same section, this polar coordinate system. You can find all of these equations there. So this will be 35 times sine of 7 pi over 12. And we know that our rectangular form for complex numbers is given as x plus jy. So if we just plug x and y into this equation, we have 35 cosine 7 pi over 12 plus j times 35 sine of 7 pi over 12. We can factor out these 35s. So that's our radius. Then we'll be left with cosine of 7 pi over 12 plus sine of 7 pi over 12. And if we check back to our answer from the first one, our final answer is distributed through and put in decimal form, but if you look here, that's exactly what we have before it was put in decimal form. So we know that our answer is the same.